Representative Concentration Pathway 8.5, or RCP 8.5, is often described as the doomsday scenario of climate change, a theoretical future where industrial expansion continues entirely unchecked and fossil fuel use actually accelerates throughout the 21st century. It represents the upper bound of what could happen if we did nothing. But as we navigate the complexities of global energy transitions in 2026, the question is no longer just about how bad it could get, but whether this scenario is even still a plausible guide for our future, or if it's become a ghost of an industrial path we've already started to abandon.
That's the central tension in climate modeling right now. RCP 8.5 was never meant to be a literal prophecy. It was designed by the Intergovernmental Panel on Climate Change, or IPCC, back in the early 2010s to serve as a high-end baseline. The idea was to give scientists a standardized stress test. If you want to see how the most extreme version of global warming affects coral reefs or polar ice, you need a model that pushes the system to its limit. The 8.5 in the name actually refers to radiative forcing, essentially the measure of the energy imbalance on the planet. By the year 2100, this scenario projects an extra 8.5 watts of energy for every square meter of the Earth's surface compared to pre-industrial times. To put that in perspective, NASA data suggests that even small changes in that balance can trigger massive shifts in global weather patterns.
But if we look at the actual trajectory of global emissions over the last decade, we aren't exactly following that 8.5 path, are we? There's a real disconnect between the business as usual label that often gets slapped onto RCP 8.5 and the reality of how energy markets have shifted since the Paris Agreement. If the scenario assumes a massive return to coal and almost no climate policy, but we're seeing record investments in renewables, is the model still performing its intended function, or is it just scaring us with a future that's no longer on the table?
It's a fair challenge. In fact, experts like Zeke Hausfather and Glenn Peters have argued in recent years that calling RCP 8.5 business as usual is misleading. When the scenario was first developed, global coal use was skyrocketing, particularly in the early 2000s. It seemed plausible then that we might just keep burning more and more. But the data from the Global Carbon Project shows that global CO2 emissions have been relatively flat for over a decade now. We're actually tracking much closer to middle-of-the-road pathways like RCP 4.5. The assumption in RCP 8.5 that coal use would increase 5 or even 7-fold by 2100 looks increasingly disconnected from a world where solar and wind are now the cheapest forms of new electricity in most of the world. However, scientists still use it because it creates a clear signal. If you're trying to distinguish human-caused climate change from natural variability in a computer model, the extreme forcing of 8.5 makes those patterns much easier to spot.
I see the utility for a lab setting, but there's a risk when that extreme signal leaks into public policy or insurance risk assessments. If a city plans its sea-level defenses based solely on an 8.5 scenario that has a low probability of occurring, they might overinvest in infrastructure they don't need. Or worse, the public becomes so overwhelmed by the apocalyptic scale of the projection that they give up on smaller, more feasible mitigation efforts. There's an intellectual honesty problem if we continue to lead with the worst-case scenario without explicitly stating how much the probability of that scenario has dropped.
The scientific community is actually course-correcting on this. The newer generation of models, called Shared Socioeconomic Pathways, or SSPs, are much more nuanced. Instead of just looking at carbon concentrations, they look at the how and why, things like population growth, technological innovation, and geopolitical stability. For example, SSP 8.5 is the modern successor to the old RCP 8.5. It envisions a world of rapid fossil fuel-led development. But there's also SSP 2.6, which represents a highly sustainable, cooperative world. The shift in 2026 is that we're moving away from viewing these as a single choice between heaven and hell. We're realizing we are likely in a muddle-through scenario. Current policies, according to the International Energy Agency, put us on a path toward roughly 2.4 to 2.7 degrees of warming, which is far from the 4 or 5 degrees projected by RCP 8.5, but still well above the 1.5 degree target we're aiming for.
So we've avoided the absolute cliff, but we're still on a dangerous road. Let's break down that radiative forcing concept a bit more, because 8.5 watts per square meter sounds abstract. If we're currently at roughly 2.7 watts per square meter of human-caused forcing, jumping to 8.5 isn't just a linear increase in heat, is it? It's about the cumulative energy being trapped. It's like adding more insulation to a house while the heater is still running. At some point, the house doesn't just get warmer. The internal systems, like the plumbing or the foundation, start to fail. fail. What are the specific feedback loops that could theoretically push us back toward an 8.5 level of warming, even if our direct emissions stay flat?
That is exactly why some researchers refuse to retire RCP 8.5 entirely. Even if our industrial emissions don't hit those extreme highs, the Earth's natural systems might do the work for us through feedback loops. A major one is the permafrost. As the Arctic warms, frozen ground thaws and releases methane, a greenhouse gas that's much more potent than CO2 in the short term. There's also the albedo effect. When white sea ice melts, it reveals dark ocean water underneath. The ice used to reflect sunlight back into space, but the dark water absorbs it, which leads to more warming and more melting. It's a self-reinforcing cycle. A recent study in the journal Nature suggested that these carbon sinks, the forests and oceans that usually soak up about half of our emissions, are becoming less efficient as the planet warms. If the planet loses its ability to clean up after us, we could end up with an atmospheric concentration of CO2 consistent with a high-end scenario like 8.5, even if we aren't burning as much coal as the original model assumed.
That adds a layer of complexity to the risk management argument. If the goal of RCP 8.5 is to define the boundary of risk, then it serves as a safety margin. But there's a fine line between a safety margin and a distraction. If we focus all our scientific resources on the 8.5 scenario, do we miss the more subtle but still devastating risks of a 2.5-degree world? Extreme heat waves, agricultural shifts, and water scarcity don't need 8.5 watts of forcing to become catastrophic. They're happening right now at much lower levels. I wonder if the dominance of RCP 8.5 in the literature has skewed our perception of what success looks like.
There's a growing consensus that we need to spend more time looking at the middle scenarios, RCP 4.5 and RCP 6.0. These represent worlds where we make some progress but don't quite get our act together. These are arguably much more difficult to plan for because they're full of trade-offs. In an 8.5 world, the signal is so loud that the answer is always evacuate or build a massive wall. In a 2.5-degree world, the questions are more granular. How do we transition our power grid while maintaining economic growth? How do we adapt our crops to shifting rain patterns without causing a food crisis? It's less about avoiding the apocalypse and more about managing a very difficult transition. The IPCC's sixth assessment report actually acknowledged that high-end scenarios are not typical of our current trajectory, but they remain useful for exploring the tail of the distribution, the low-probability, high-impact events.
It's almost like a flight simulator. You want the pilot to practice for the engine fire and the total hydraulic failure, even if those things almost never happen. Because if they do, the consequences are total. But you also need them to practice landing in a crosswind, which happens every day. RCP 8.5 is the engine fire. It forces us to ask, can our civilization survive this? But the shift in 2026 seems to be toward realizing that our real-world landing is going to be in that messy, complicated crosswind of 2.5 degrees.
Exactly, and we should acknowledge the progress that made 8.5 look so unlikely. A decade ago, the idea that the world would be spending over $1 trillion a year on clean energy seemed like a pipe dream. But in 2022, we hit that milestone. Coal consumption in the US and Europe is plummeting. Even in China, while they're still building coal plants, the growth in their solar and wind capacity is so massive that it's starting to displace the need for those plants to run at full capacity. The pathway part of RCP 8.5 assumed we'd be blind to the consequences of our actions, but humans have proven to be much more responsive than the 2011 models predicted. We've effectively bent the curve. We haven't flattened it yet, but we've stopped the vertical climb that RCP 8.5 represented.
The terminology itself, representative concentration pathway, is also a bit of a misnomer for the general public. Concentration is the key word there. It's not just about what we emit this year, it's about the total stock of gases in the atmosphere. Even if we stop all emissions tomorrow, the CO2 already up there stays for centuries. That's why even the lower scenarios still show warming for decades to come. When people hear that we're tracking lower than the worst case, they might think the problem is solved. But the physics of radiative forcing doesn't care about our intentions. It only cares about the molecules in the air. We're still adding to the stock every day, just at a slower rate than the 8.5 scenario feared.
That's a crucial distinction. Think of it like a bathtub. The water level is the concentration of CO2. RCP 8.5 assumed we'd turn the faucet on full blast and then leave the room. Our current reality is that we've started to turn the handle. The flow is slowing down slightly, but the water is still rising. The goal of scenarios like RCP 2.6 is to turn the faucet off and then find a way to pull the plug to let some water out, what we call carbon removal.
Rcp 8.5 is essentially the scenario where the bathtub overflows and floods the entire house. Even if we don't think that's going to happen anymore, we still need to know exactly where that overflow point is so we can stay as far away from it as possible.
Looking at the cultural impact, RCP 8.5 has really dominated the headlines. Most of the scary maps you see of flooded cities or uninhabitable zones are based on 8.5. It's become the default setting for climate communication because it makes for a more compelling story. But if that story loses its credibility because the underlying economic assumptions, like coal use, are no longer true, does that undermine the entire scientific message? There's a risk of a boy who cried wolf effect if we don't update our benchmarks to reflect the actual progress we've made.
That's the fine line scientists have to walk. You want to be accurate about the progress, but you don't want to encourage complacency. If you say, hey, RCP 8.5 is dead, some people will hear climate change is over. In reality, a 2.5-degree world is still a world of massive migration, lost biodiversity, and increased natural disasters. The irony is that by focusing so much on the extreme 8.5 scenario, we might have accidentally made a 3-degree world look like a win. But for a farmer in the Sahel or a resident of a low-lying island nation, 3 degrees is still a catastrophe. The value of Rcp 8.5 moving forward might be less as a prediction and more as a historical artifact that shows us exactly what we've managed to avoid through policy and technology.
It serves as a mirror of our potential. It reflects what a world without any international cooperation, without any technological breakthroughs in batteries or solar, and without any concern for the future would look like. In that sense, the evolution of these models is a testament to human agency. We aren't just passengers on a predetermined track. The pathways are something we build as we go.
And the models are getting better at capturing that agency. The move from RCPs to SSPs reflects that shift from a focus on the physics of the atmosphere to a focus on the choices of society. We're starting to understand that the climate isn't just something that happens to us, it's a reflection of our economic systems, our diets, our travel, and our politics. RCP 8.5 was a model of a world that didn't care. The newer models are trying to map out a world that is at least trying to care, even if it's struggling with the execution. In 2026, we find ourselves in the gap between what we feared would happen and what we hope we can still achieve. It's a much more hopeful place than RCP 8.5, but it's arguably more demanding because the solutions now require precision and persistence, not just alarmism.
The persistence is the hard part. It's easy to be motivated by a clear and present danger, like the one RCP 8.5 describes, but it's much harder to maintain that same level of urgency for the slow, grinded-out work of decarbonizing a global economy over 40 years. We've effectively avoided the immediate crash, but we still have to navigate the rest of the journey without falling asleep at the wheel. The 8.5 scenario remains in our rearview mirror as a reminder of where we could have gone, and perhaps that's the most useful place for it to be.
It's a powerful reminder. Even as we update our models and refine our projections, we have to respect the data. The physics of 8.5 watts per square meter hasn't changed. If we somehow went back to a coal-heavy economy, or if the feedback loops trigger a massive methane release, those numbers are still there, waiting for us. The risk hasn't disappeared, we've just chosen a different path. The challenge now is to make sure that the path we're on leads somewhere we actually want to live. By studying the extremes of RCP 8.5, we've learned the value of every fraction of a degree we can save. It turns out that the difference between the end of the world and a manageable crisis is often found in the choices we make today.
It's ultimately a story about the power of information. We saw the 8.5 path laid out in front of us a decade ago, and as a global community, we started making different turns. We aren't all the way there yet, but the fact that RCP 8.5 is now debated as an unlikely scenario is actually a sign of extraordinary success. It shows that when we have clear models of our future, we have the ability to change them. The doomsday was never inevitable. It was a warning that we actually listened to.
That is the ultimate takeaway. The scientific rigor behind these models isn't just about predicting the weather, it's about giving us the tools to decide our own destiny. Whether we're looking at the extreme forcing of 8.5 or the more sustainable paths of 2.6, the focus remains the same: understanding the world well enough to save it. As we continue to refine these pathways, we move closer to a future where these models aren't just warnings, but blueprints for a stable and prosperous planet.
Understanding these climate pathways helps us see the direct impact of our global decisions on the air we breathe and the future we're building. If you found this exploration of climate modeling insightful, consider sharing it with someone who might be interested in the science behind our planet's future.